Hello, my name is Hilton Hammond. Welcome to this dynamic scientific presentation on cannabis cultivation and processing. This presentation is all about using scientific data to improve quality, consistency, and techniques to maximize the cannabis potency sales potential. Cannabis cultivation techniques and methods vary, but no matter what method you use, the plant's cannabinoid development will also vary depending on strain, technique, and conditions. Understanding what works and what does not work will identify ways to improve processes and techniques that lead to improvement on potency output, quality, consistency, and ultimately sales. Like any living organism, a cannabis plant has needs, likes and dislikes. Getting the most out of a strain or crop demands understanding their likes and dislikes and being able to measure the productivity in a quantifiable and qualitative way. With data, you can make measurable adjustments to optimize your environment, processes, and methods so that you can get the most out of a strain and crop. Without measurable data, you are pretty much left to relying on experience, subjectivity, and guessing. By now you've most likely mastered the basic techniques, and you have more than likely developed a good product using a formulation of water, light, humidity, and carbon dioxide, as well as the nutrient needs based on industry guidelines and, of course, personal experience. You've also likely put in place measures to minimize infestation and control diseases. You can achieve the next level of potency, production, efficiency, and quality by adjusting and managing the exact nutrient additions during the growing cycle. These adjustments can make a big difference in the cannabinoid potency. You can also use measurement data to understand the best timing of when to harvest, how long to dry or cure, and even monitor storage shelf life to understand the aging processes, and be able to take necessary actions to avoid spoiling a batch. An even worse case scenario is shipping a product below customer expectation. With data, you can also experiment with different strains and different cultivation techniques to really understand how to optimize its productivity and take the quality and consistency to the next level. In today's presentation, we aim to share with you the basics of using scientific data to achieve that next level. As I mentioned in the previous slide, the objective of today's seminar is to learn about how to test and measurements can be used to maximize the revenue potential of your produce. We're not going to cover things like integrated pest management or local regulations. These topics are well covered by other subject matter experts. What we do plan to cover is how to precisely manage nutrient additions throughout the plant cycle, using cannabinoid test data to manage the overall process, timing, and fine-tuning adjustments needed to maximize the THC and CBD, and using experiments with data to learn how to optimize a strain or improve processes. Ultimately, the goal is to increase production of cannabinoids, increase consistency, and improve quality. In this presentation, we plan to break down the variances that impact the production of THC and CBD into three parts. Part 1, we will talk about how to make the right measurements to precisely adjust the nutrient additions as the plant develops through the vegetation to flowering stages. In Part 2, we'll talk about how to use high-performance liquid chromatography measurement data to make the fine-tuning decisions and precisely understand the timing of harvesting and curing in order to maximize the extraction and packaging of THC and CBD. What is important to understand here is the cannabinoid strain development over time. They will vary depending on growth conditions and even growing techniques. Using data to better understand how the crop THC and CBD develops over time and with varying conditions is critical to making the fine-tuning type of decisions in order to maximize a crop potency output. Lastly, we'll show you a couple of basic experiments you can put in place to learn a particular strain likes and dislikes. These experiments can be extremely helpful in optimizing processes and maximizing potency, or refining processes to deliver consistent and quality product. So let's start by talking about the plant's nutrient needs as it goes through the vegetation to flowering stages. When it comes to the nutrients, we can break them down into two parts, where the primary nutrients are nitrogen, phosphorus, and potassium, or commonly known as N, P, and K. The secondary nutrients that can have an impact on cannabinoid development is calcium, magnesium, sulfur, or CAMGS for short. If you're following industry guidelines, they will typically recommend additions of nitrogen in the 300 parts per million range, phosphor in the 60 part per million range, and potassium around 215 parts per million during the vegetation stage. Then as you go into the flowering stage, the industry guidelines will make recommendations to change around the phosphor around 100 parts per million, nitrogen down to 70 part per million, and potassium around 200 part per million. The key question becomes, how much do you need to add? Because essentially the flower is going to consume what it needs. Therefore, in your particular condition, logically, how much N, P, or K should be added to the existing base in order to provide exact levels going forward? Adding too much or too little of any one nutrient can have adverse consequences. So how do you measure the nutrient content in the soil? There are various methods. We recommend the ultraviolet visual light spectrophotometry technology to measure the concentration of specific nutrients, as it is able to get down to specific primary or even secondary nutrient concentration levels. UV Vis spectrophotometry offers the most versatile and accurate solution. How does it work? UV Vis spectrophotometry is a technology that is based on the theory that different molecules will absorb energy from light at different wavelengths. You can identify the molecular group by measuring the wavelength at which the molecule absorbs the highest amount of energy. We can also determine its concentration level by comparing the energy level absorbed of the unknown sample to a known calibration reference sample. This is the most effective way to accurately determine the nutrients and its concentration, making it easy to determine how much precisely needs to be added. Having this type of data makes it possible to do data-driven experiments to learn a strain's particular likes or dislikes. And we'll get into more about that later. Let's talk a little bit about the common methods for testing soil nutrients. We've just spoken about UV Vis spectrophotometry. It is a method that can accurately identify and measure the concentration levels of individual nutrients. This is an established method used in industry and science to measure specific compounds of interest. The other method is total dissolved solids, or TDS. Total dissolved solids measures or tests for the total organic matter and inorganic salt dissolved in a water, and it's typically expressed in milligrams per liter or parts per million. The challenge with the TDS method is the test actually looks at the total amount of N, P, and K and other micronutrients combined. it cannot specifically define the amount of or the concentration levels of each individual element in the soil. Essentially, it can only tell you how much organic matter or inorganic salts are present. Therefore, you can only assume the individual nutrients have been depleted equally and therefore only add back a given ratio of N, P, and K. The result is you could end overfeeding one nutrient while underfeeding another. In this example, we monitored the nutrient level in hydroponic growth media on a weekly basis. During the growth stage, industry recommends the concentration level of N, P, and K is 300 part per million, 60 part per million, and 215 part per million respectively. Using the UV Vice spectrometer, we obtained the following results in our experiment: 220 part per million, 60 part per million, and 180 part per million. Looking at these results, you can clearly see where the deficiencies lie, and we can easily make precise adjustments to make sure that our nutrient conditions are following guidelines, or the exact concentrations of your specific strain based on data-driven experimentation with your specific growing conditions or technique. Let's go over a few of the benefits of using UV Vice spectrophotometry measurements. Firstly, you can learn exactly when to make adjustments, which nutrients and how much needs to be added and replenished during the growth to flowering stages. You can also identify which part of the crop, if you've got a large field, that needs to be replenished to avoid over or underfeeding in particular areas. In addition, by sampling often, you can stay ahead of the flower's demand and therefore avoid any potential future development issues that may occur out of under or overfeeding. Ultimately, by using data, you can get to know the plant needs, eliminating guesswork. Will give you an advantage in terms of being able to identify specific needs and adjustments to make improvements to quality and consistency. Cannabinoid development is a complex and natural process. There are many variables that need to be taken into account in order to make sure that you produce the maximum concentration levels from the desired strain. Once the crop is harvested, the next stage involves yet another set of complex processes and variables. The question becomes, how do you know when to harvest, how long you should cure the product for, and at what temperature should you cure the product in order to fully decarboxylate the cannabinoids to provide the desired effect. And of course, it all depends on what you're starting with, how much was there to begin with. The worst case scenario being that the curing process was too long, or temperatures too high, or the product was left exposed, allowing the cannabinoid to degrade. For example, CBN is formed through degradation and oxidation of THC. Shipping product that falls short of expectation is not an option for establishing your brand in the market. The common method of measuring the potency, other than sending a sample to a lab, is the indirect method. By using our senses of observation and smell, the indirect method relies wholly on human experience and is very subjective and can easily be misinterpreted. This makes it very difficult to achieve consistent, repeatable results. The second method, which is the golden standard in the industry for testing cannabis sample potency, is the direct method, using high-performance liquid chromatography. Next, we will review how the technology works. Liquid chromatography is based on its ability to separate individual compounds in a solution. HPLC system can be broken down into 4 distinct parts: the carrier solvent, which is known as the mobile phase, the high pressure pump, the liquid chromatograph column, and lastly the detector. The column is the most critical component in the system and is known as the stationary phase. The column is packed with very fine particles typically micrometer-sized silica that once packed form very small pores that the solvent and sample flow through. As the solvent and sample flows through the column, the unknown sample compounds interact with the stationary phase, causing the compounds to pass through the column at different times due to the different sizes and molecular structure of the individual compounds. The lighter, smaller compounds come out first, while the larger and heavier compounds come out last. The time it takes for individual compounds to exit the column is referred to as the retention time. Once the compounds are separated and exit the column, they are passed through a light detector. Similar to the UV vis spectrophotometer, the light detector measures the absorption of light energy at specific wavelength, where the absorption level is directly proportional to the density or compound concentration. By comparing the retention time and absorption level of the separated sample compounds to a known calibration reference, we can identify the cannabinoid and accurately measure the concentration level of each. There are three prevailing methods for measuring THC or CBD potency. As we already discussed, the indirect method relies on human experience and is very subjective, that will lead to inconsistencies. Another technology that is being used is near-infrared technology. NIR can be used to detect compounds, but to improve its accuracy, NIR must be used in conjunction with testing samples with an HPLC system. Lastly, as we already discussed and demonstrated, HPLC is the industry-accepted standard for testing and analyzing cannabinoid content and can be relied upon to make informed decisions using accurate test data. I will start by first explaining the graph and the table data. The graph is arranged by showing the light detector absorption signal level over time as the separated compound exits the column. The light detector measures the absorption. The higher the density, the higher the level of absorption. What you see in the trace are the individual compound peaks absorption levels or relative concentration as they exit the column. This graphical representation of the compounds is a great way to visually see what is going on, either from a batch-to-batch basis, A versus B experiments, or oftentimes it is used for quality assurance purposes. Seeing what is different or changed is often the first step to understanding what is going on. Using the individual peak signal levels, the system will calculate the concentration in milligrams per liter, or when the dilution factor is known, the concentration in milligrams per gram can also be calculated. In our example here, we use the graph and table data to compare with our target expected cannabinoid content. No subjectivity, but pure data-driven decisions. Notice how the HPLC system detected low levels of THCV, which is an early indicator of possible degradation due to aging or exposure. In this example, at an oil extraction and processing facility, each batch of extract is analyzed for quality control and consistency, making it possible to separate, combine, or reject the different oil extracts batches to make sure you're producing a product with a desired formulation and hitting the target THC and CBD potency. We started out the presentation asking several questions related to better understanding what's going on with cannabinoid development and using scientific data to make informed decisions so that you maximize THC and CBD production. There are three key benefits of using HPLC instruments, obviously beyond meeting regulatory product intro and labeling requirements. These benefits are: 1. The data can be used for technique optimization, process improvements, and quality control. Using cannabinoid data, you can gain better insights into particular strain likes and dislikes, and of course, adjust your formulation accordingly. 2. The data can be used to make real-time adjustments and decisions throughout the plant life cycle in real time, and post-processing without having to guess at what's going on with the flower. Lastly, the data can also be used for R&D purposes. By conducting small batch experiments, you can establish and define specific quality attributes to make sure your product consistency exceeds customer expectation. Product consistency being the key. Conducting small batch A versus B type experiments are a great way to learn more about a strain so that you can create standard operating procedure and establish a cannabinoid fingerprint before going into mass production. Experimenting with various variables from light, nutrients, as well as measuring the cannabinoid output can help dial in your process. Having this level of understanding based on qualitative metrics will lead to producing a great product with better consistency. Ultimately, as a producer of cannabis products, consistency is key to growing your business. Using instrumentation and data to help guide, manage, and make decisions is the first step to achieving that objective. A simple way to experiment is by conducting A versus B comparisons. In this example, we picked one key variable at a time. Make quantitative adjustments to a formulation or process, and then compare the outcome in terms of cannabinoid production. In this example, we chose to compare different levels of N, P, and K nutrient additions to see the outcome on THC and CBD production. In this example, you can see how the different experiments turned out with different levels of THC and CBD. Continue experiencing with various other variables one at a time to really get to know a strain's likes and dislikes. We have covered a lot of ground and some of it quite technical, so I want to highlight how dynamics can help and support you as you build your quality and R&D capability. Using scientific data to advance your techniques without any help can be a daunting task to take on. Dynamics can help with just about every aspect, from the instrumentation, the sample preparation equipment, to training and standard operating procedures. Contact Dynamics to talk through all aspects of how to get set up to bring scientific data to your operation. Here's a quick summary of the key points from the presentation. Nutrients are a critical element to cannabinoid development. Understanding how much is needed to replenish the soil to avoid over or underfeeding is key to ensuring you maximize production. Using the dynamic spectrophotometer will provide the exact part per million level data to make precise adjustments as the plant's needs change from vegetative to flowering stages. Knowing what is going on with cannabinoid production and making adjustments in real time can be a huge difference maker in producing quality product with consistency. The Dynamics L3000 HPLC system is based on the industry gold standard for separating and analyzing cannabinoids. Then lastly, putting in place data-driven experimentation will give you the necessary insights to put standard operating procedures in place to ensure you hit your quality targets from batch to batch. Furthermore, use the outcome from these experiments to establish qualitative metrics and product cannabinoid fingerprints to use as a baseline to compare against. Having a comparison point will arm you with the data to better understand what's changing from batch to batch. Before we close off the presentation, I invite you to reach out to Dynamics and ask questions and learn more about our product solutions, or enjoy a live demonstration of the cannabis analysis in action. Contact us by emailing info@dynamics.com. Thank you for your time. I hope you have learned something that will help you advance your cannabis cultivation, and we look forward to talking with you.